Welcome everyone, welcome to my channel Marine Sea Time. Today I will be discussing about the operation of the air conditioning plant on ships. So on the last lecture I have talked to you about the heating, ventilation and the air conditioning unit of a ship. So let me give a brief explanation of that chapter. So on that chapter I have told you this is the return air, this is the recirculation air, this is a mixing section, this is a filter section, heating section, cooling section, humid section, water elimination section, and this one is the fan section. So in this lecture I will be talking about this cooling section. So in this cooling section we have a evaporator coil over here. So after this evaporator coil the refrigerant goes into the compressor, then condenser, then after it goes through the solenoid valve, then through the thermostatic expansion valve, and then returns back to the evaporator. So I will be telling how this what are there in this compressor and condenser and this evaporator. So let's begin. In this you can see over here. So this one is the compressor over here. Now this one is the compressor, this one is the condenser, this one is the receiver, and this one is the condenser, and this one is the compressor switchboard. And then we have one now this one this one is the liquid separator, this one is the liquid separator, and this one is the liquid cooler. So so you can see over here the refrigerant from the refrigerant from the evaporator comes into the liquid separator, and from this liquid separator the refrigerant goes into the compressor, and after compressing the gas the refrigerant goes into the receiver and then to the condenser, and after that it goes into the liquid cooler. So this one is the liquid cooler over here. After that this refrigerant will go into the solenoid valve and thermostatic valve, and then after it will go to the evaporator. So this one I will be talking about this liquid separator. So this one is a liquid separator. So what is the function of this liquid separator? So after the evaporator the refrigerant is almost in a gaseous state, but if suppose if there is some liquid left in this in the refrigerant after leaving from the air cooler, then the liquid will be accumulated in this liquid separator in the liquid state. From the liquid separator the possible excess of refrigerant will gasify, and it will be sucked back to the compressor together with small quantities of oil until the separator has been emptied again. So so the liquid will be so if there is some liquid after the evaporator, so it will accumulate in the this liquid separator, and after accumulation in the liquid separator, it will gasify, and after gasification it will be sucked back to the compressor, and and it is gasified until the separator has been fully emptied. So the this separator will be fully emptied because it will gasify and the compressor will take suction from this liquid separator. So what is now what is the function of this liquid cooler? So liquid cooler it is there to subcool the refrigerant after the condenser. So you know this in the diagram, you know that uh, so this one is the diagram. So we subcool the refrigerant from here. After the condenser we subcool the refrigerant, so that to prevent the flash gas going into the expansion valve and causing incorrect regulation of the refrigerant. So, so this is the use of this liquid cooler. It is to subcool the refrigerant after the condenser. Now in the condenser you can see over here these are the two gauges. So these gauges which has two marking over here. So you can see we have two marking. So one is for suction pressure and the other one is for oil pressure. And at the discharge side you can see over here, so this one is the discharge side pressure of the liquid refrigerant passing after the compressor. So this is the discharge pressure, and this is the suction pressure. Suction pressure is of dual gauge type. Now here, this one all is the expansion type of pipeline, and here you can see we have this KP15. So you can see this P. So what is the function of this P? So P will measure the low pressure inlet to the low pressure control and the high pressure control. So this P will measure the low pressure and the high pressure of the refrigerant from the inlet and from the outlet side. So from the inlet side it will measure the low pressure, and it will actuate the low pressure controller. Now if suppose at the inlet to the compressor, if the pressure of the gas is low, it can be due to many reasons. So pressure of the gas is low, so the LP switch will activate, the LP switch will deactivate, and it will stop the compressor. So this switch is directly connected with this junction box. So if there is high pressure at the discharge side, that is HP cutout, then it will trip the compressor when the discharge side pressure increases above the limit value. So HP cutout is not auto reset and has to be done manually. Okay, so we cannot reset this auto HP cutout, so we have to manually reset this. The HP cutout is mainly occurs due to the very high temperature of the water inlet to the condenser. So this is the main reason of high pressure cutout in the compressor. Now you can see in this we have a oil separator over here, which will, at the discharge of the compressor, we have a oil separator. In the oil separator we have a relief valve. You can see this is the relief valve at the outlet of the, so we have a relief valve. So in the oil system, if the relief valve is set to about 2.5 bar above the crankcase pressure. Now this is the reciprocating compressor. In the air conditioning unit, we have a V type or W type compressor with almost 8 to 12 or even 16 cylinders in the compressor. And in the compressor also we have a unloader valve, unloader valve. So you can see this 3 pressure gauge, P, 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 P. So these are the 3 pressure gauges. These are the 3 pressure sensor which will sense the pressure at the inlet to the compressor, and accordingly it will open and close the valves of the compressor unit. So you can see during light load only 2 cylinder will be operations, and during more than that 4 cylinder will be in operation, and more than that 6 cylinder will be in operation. So depending upon the pressure of the pressure at the inlet to the compressor, the unloading valve operates. So unloading cylinder take place during starting and for subsequent load control by holding the suction valve off their seats by suitable oil pressure operated mechanism. So I will tell you later on how this unloader works. Now in the compressor, the valves are plate type suction and delivery valves whose large diameter and small valve lift offers the least resistance to the flow of refrigerant gas. So gases from the evaporator passes through the strainer housed in the suction connection to the machine. So in the suction of the compressor we have a strainer over here, and you can see so in this figure you can see this is the expansion type of pipe over here, and here we have a low pressure differential oil pressure cutout MP55. So this MP55 is the low pressure differential oil pressure control. So if the oil pressure is very low, if suppose the oil pressure is very low, oil is supplied to the bearing and the crankshaft seal by through a gear pump. Now if there is a loss of the oil through the compressor, which can cause the oil failure in the bearing. So this low pressure differential oil pressure will sense the oil pressure in the crankcase, and will and this and it will activate a trip signal to safeguard the bearing and the crankshaft. Now you can see here we have a receiver. This is the condenser over here. So here you can see we have a purging valve. If suppose there is an air accumulation in the condenser and the receiver, So by this purging valve we can remove the air. Now you can see we have a relief valve over here on both the condenser and the receiver, and this relief valve is discharged it discharged in the atmosphere. Now after that you can see this is the liquid charging valve from where the liquid is charged into the refrigerant system. Now you can see this one is the dryer. This one is the dryer and this is the liquid side glass. So if there is any water accumulation into the this system, then this can actually choke the thermostatic expansion valve. So that is the reason we use this dryer into the system, because water can freeze on the expansion valve, causing excess pressure on the condenser side and starving of refrigerant to the evaporator. When this occurs, the compressor will cut out due to the operation of the high pressure cutout or low pressure controller. The presence of a small amount of water can have an effect on the plant performance, and dryers are essentials. So the dryers are usually made up of silica gel or activated aluminum. So this dryer will take all these water from the refrigerant system. And we have a side glass over here. So there is a cylindrical or circular glasses installed on the liquid line, providing a means of ascertaining whether or not the system is fully charged with refrigerant. If undercharged, the vapor bubbles will appear in the side glasses. To be most effective, indicators should be installed in the liquid line as close to the liquid receiver. So this will actually detect if the refrigerant is undercharged or fully charged. If it is undercharged, the vapor bubbles will be formed into the side glass. So by seeing this, we can check if the system is undercharged or not. After that, after passing through this side glasses and this dryer, the refrigerant goes into the liquid cooler, and at the liquid cooler the refrigerant is subcooled. You can see there is thermostatic expansion valve in this liquid cooler also. Now after this liquid cooler, the refrigerant will go into the evaporator. So you can see over here, this is the air cooler. So the refrigerant gas after this after passing through the liquid cooler, it will go into the solenoid valve. So we have two solenoid valves, number 1 and number 2. These two are the solenoid valves, and these two are the two thermostatic expansion valves. The solenoid valve will open or close depending upon the temperature of the air flowing into the accommodation. So I have told you that there is a thermostat at the outside of the outside at the delivery section. So this thermostat will be directly connected to the solenoid valve, and it will open and close the solenoid valve according to the air temperature. If the desired temperature is maintained, then solenoid valve will automatically close, and it will not allow the refrigerant to flow into this air cooler. Now after passing through this air cooler, the refrigerant will go into the compressor. So here you can see how this this is the here you can see this is the motor, this is the belt driven. So this is the belt driven. You can see this one is the liquid separator over here, and at the back side we have a liquid cooler. You can see this is the V-shape compressor. This is the air conditioning compressor, V-shape, and you can see these are the valves. So this is the discharge valve. This is the compressor outlet. You can see over here. Now you can see these are the solenoid valves, which will control the capacity of the refrigerant. Now So this is how the capacity is controlled. You can see these are the unloaders. You can see these are the unloaders, and you can see these are the solenoid valves. These are the pressure switches which I have shown you before. We have 3 pressure switches. According to the pressure switches, the solenoid valve will open. You can see the solenoid valve will give signal to the solenoid valve, and as the solenoid valve opens, the oil, it gives part to the oil, and this oil will go into uh, this spring loaded valves, and will open the valve depending upon the load. So we have 33% load, then we have 66% load, and then we have 80% load. So if there is 33% load, so if the load is 33%, then the valve and the valve will be closed. No refrigerant will pass into the so if we have 6 cylinder, then in only 2 cylinder the refrigerant will flow. And suppose it is 66% load, then at 4 cylinder the refrigerant will flow, and if it is 80% load, then at 6 cylinder the refrigerant will flow. So you can see how this refrigerant flows via the oil pressure. So why there is need of this capacity control? So if suppose you are in a colder region, then there will be always an LP cutout, because in the colder region the temperature of the the temperature is always reached. So there will always be an LP cutout into the system. LP cutout. So there will be always an start stop continuous operation, and this way the motor contractor will definitely will burn out due to this. So if the ship goes into a colder region, which where temperature is almost 15 to 25 degrees Celsius, so at that temperature there will always be an LP cutout. So that is the reason we have this unloaded capacity control type of unloader in the air conditioning system. Now if suppose the load is very low, then only two if suppose the load is 33%, then only 2 cylinder will only open. Now if suppose the load is very high, suppose it is 80%, then all the 6 cylinder will open, and it will prevent the LP cutout in the system. So there are 33% 33.3% capacity, 100% capacity. So you can see these are the solenoid valves. This blue color are the solenoid valve. You can see how we have one line from this. So how this one line from this to this solenoid valve, you can see this line. So as the solenoid valve opens due to these pressure switches, the oil will go into the compressor valves, and it will open or close the valve accordingly. So the capacity regulation of the compressor is controlled by the suction pressure based on the air inlet temperature of the air handling unit. So a pressure controls type in the suction line control the engagement and the disengagement of the compressor cylinder by means of 3-way solenoid valves. So I have talked to you about the liquid separator, liquid cooler, and we have 4 solenoid valves placed in the liquid line before the air cooler, and 2 electric sensor is placed on the mixing section at the AHU. When the electric sensor reaches the set point, it will give an impulse to the solenoid valve to shut off the liquid supply to the air cooler, and the low pressure control will then stop the compressor. So this was all about, guys, operation of the plant in the air conditioning system. So hope you like the video. If you like the video, please like and share, and if you haven't subscribed till now, please subscribe the channel to get more videos like this. Thank you. God bless you all.